Hey guys, so today we're going to do an arithmetic sequences and series overview. We're going to talk about what they are, some formulas associated with them, and so let's just jump into it. I'm going to write one right here. We're going to have 1, 5, 9, 13, and ... That implies it continues forever. Okay, so what is an arithmetic sequence? Arithmetic means addition. So we're going to be adding something. Arithmetic implies adding or subtracting some common difference. So if we look at this problem that I just wrote down, what do you think the common difference is? Subtracting common difference. We can see that it's 4 in this case. So just quickly, before we get into formulas, you can kind of tell what we're going to be working with when we work with these series. If I said, what is the fifth term? I think all of you could tell me it's going to be 13 plus 4. It's going to be 17. I think everyone who's watching this would know that. So now let's get into some tougher things. What if I said, what is the 10th term? Now that's something that you could do it, but it would take a while because you're going to be adding 4 each time. So that's where the formulas come in. And so we have two types of ways to express it. We have an explicit formula, which is kind of the one that you want to use. Then we have this thing called a recursive formula that uses the previous value to get the next one. And so explicit I'm going to define as a of n. N is just the number of the terms. So this would be a of 1, a of 2, a of 3, a of 4. You get the point. And a of n equals, it's going to be n minus 1 times d plus a of 1. And then recursive is going to be a of n. And no, every time you do a recursive, so this applies to geometric, which you'll learn eventually, I'm sure, if you don't already know. The recursive formula, so we're going to have a, you know that you're going to have to use a of n minus 1, because that was the previous term. And then you're just going to add the difference. And that's it. So now let's try to plug some stuff in. Let's just make sure that we know what we're doing. So let's take a of 3. We know what it is, but we're going to solve for it anyway. A of 3, that's this term right here, it's the third term in the sequence, equals, and then it says n minus 1. Well, we just decided that our n was 3, so 3 minus 1 times our difference, which we said earlier was 4, plus a of 1, this just means first term. And well, we know the first term right here is 1, so plus 1. Alright, so then a of 3, let's simplify a bit. It's going to be 3 minus 1, we can just say is 2, times 4, plus 1, 8 plus 1, so a of 3 equals 9. Is that what we got? Yep. So that tells you that we know what we're doing. We figured it out. So now let's try recursive just to get an idea of how that works. Let's find a of 4 using the recursive formula. So a of 4 equals a of 4 minus 1 plus d, which is 4. So a of 4 equals, well, a of 4 minus 1, that's a of 3. We know a of 3 is 9, so 9 plus 4. So that's going to say a of 4 equals 13. And that's exactly what we had here. So that's just to check, make sure we wrote these right. So these are the two formulas you need to know for recursion and the explicit. And now let's get into some of the, well, the one harder topic really, which is the summation of these things, of these arithmetic sequences. So that is a formula that we can write as S of n equals n divided by 2 times a of 1 plus a of n. And now let's make up a new sequence here. I'm going to start with negative 5, 2, 9, 16, ... Okay. So, and I want to find S10. So what that means, what I'm asking here is I want to find the sum of the first 10 terms. That's what that subscript right there means. So S of 10, and then you can see it again as this n. That's what the 10 comes from. So every time we see n in here, right there and there, we're just going to plug that in. So it equals 10 divided by 2 times a of 1 plus a of 10. Then I'm going to say, okay, I know my a of 1. That's always the first term in the sequence, a1. But I don't know a of 10. I know it's somewhere out here. I don't know what it is. So I got to figure that out. And the way I'm going to figure that out is I'm going to use this explicit formula that I just made up. It won't be the exact same, but it'll follow the same pattern. So it'll still be a of n equals a of 1 plus n minus 1 times my difference. Okay, so I've got a of n equals, well, a of 1 is given as -5 plus n minus 1, I'll just leave that as n minus 1, times the difference, which we said is 7. It's counting up 7 every time. 7, 7, 7. Okay, so 7. And now I'm going to solve for my a of 10, because that's what I'm looking for here. So a of 10 equals -5 plus 10 minus 1 times 7. A of 10 equals -5 plus 9 times 7, 63. A of 10 equals 58. So now I've got my a of 10. I already knew my a of 1. Now I can really plug it in and solve this sum. So that's 10 over 2 is going to give us 5 multiplied by -5 plus a 58. Okay, so it's going to be 5 times 53. We can do that right here. 53, 5. 5 carry 1, 26, 265. So sum of the first 10 terms equals 265. That's probably all you're going to have to know for series of arithmetic. I'll have a lot more videos of practicing. I just wanted to have one video where I kind of say everything that you really need to know. These formulas, there's 1, 2, the third is right here. If you're going to take anything away from this video, make it these formulas. You'll definitely need them. Hope this was able to help. Let me know if you have any questions. Let me know what type of problem videos you want to have. I'll be releasing some a few days from now. So thanks for watching, guys.